Hello students, now today we are going to discuss Laplace transform. In previous class I have already told you on the basics of Laplace transform. So when you are going to derive the Laplace transform of any function, some basic functions, so how will you determine the Laplace transform of a particular functions? In first class already I told you the Laplace transform of t square and t cube or t to the power n. So already I know I have discussed the Laplace transform of t to the power n is nothing but factorial n divided by s to the power n plus 1. So already I told you the Laplace transform of t, Laplace transform of t if n equal to 1. So that is your what? That is your 1 by s to the power 1 plus 1, that is 2. Similarly, Laplace transform of t to the power 2, when n equal to 2, that is your factorial 2. Factorial 2 is nothing but 2 into 1, that is 2. 2 divided by s to the power 2 plus 1, that is your what? 2 by s cube. If I will say Laplace transform of t to the power 3, that is your factorial 3 divided by s to the power 3 plus 1, and which is nothing but 3 factorial 3 equal to 3 into 2 divided by s to the power 4, that is your 6 by s to the power 4. So t to the power any number, t to the power 1, t to the power 2, t to the power 3, like this you can use this formula factorial n divided by s to the power n plus 1. In previous class already I told you and derive how to find the Laplace transform of a t. So t is in time domain. In Laplace transform we have converted a time domain into frequency domain. So if f of t is your time domain function, f of t, the Laplace transform of t is nothing but what? That is your f of s. And f of s, here s equal to, that is your sigma plus j omega. Here sigma and j omega, omega is your radiant frequency and sigma is your Napier frequency. That is your what? If I will say, and this x axis is nothing but sigma and this is not, this axis y axis is your j omega. So any time function can be converted into frequency domain by means of Laplace transform, and here a t domain to s domain, s is your frequency, s equal to sigma plus j omega. So t to the power 1, t to the power 2, t to the power 3, so t to the power any number, so we can use this formula factorial n by s to the power n plus 1. So already I told you in your previous class. So now that is your today we are going to derive the Laplace transform of some basic functions. What are the basic functions? Suppose if I will say that is your exponential functions. If I will say exponential function, that is your f of t, if f of t equal to, that is your e to the power minus a t, here a is any scalar quantity. If f of t equal to e to the power minus a t, we are going to find out the Laplace transform of f of t. So e to the power minus a t is your exponential decay function. So what are the Laplace transform of this function? So that is what? If I will say, see this is nothing but, this is your exponential function, and if I will say t, and this is nothing but what? That is your f of t. So now we are going to derive, that is your Laplace transform of this basic function f of t. So already I told you f of t, Laplace transform of f of t is nothing but what? That is your f of s. So that is your what? Or f of s equal to, that is your 0 to infinite, or my f of t into e to the power minus st dt. This is your Laplace transform of any function. That is your basic standard formula to find out the Laplace transform of any function. That is your f of t, that function into e to the power minus st dt. And here the value is how much here? That is your, which equal to 0 to infinite f of t. Here f of t is your e to the power minus at. In place of f of t, you can put e to the power minus at. E to the power minus at into e to the power minus st into dt. So that is what? That is your 0 to infinite, that is your e to the power minus at minus st, that is your s plus a whole into t. If you taking common minus, e to the power this, e to the power this, that means you will add this power, e to the power minus s plus a whole into t. If you will integrate this function e to the power any function integration e to the power that function. So that is your e to the power minus s plus a t divided by with respect to t, that is your minus s plus a, and the limit is your 0 to infinite, and this is nothing but what, that is your 1 by minus s plus a taking common, that is your what, put the upper limit, that is your infinite. So e to the power in place of t, if you put infinite, e to the power minus infinite, that will be 0, and minus lower limit e to the power 0, that is 1. So if you put the upper limit infinite, e to the power minus infinite, that is your 0, and minus if you put the lower limit 0, e to the power 0, that is 1, and the value is how much here, that will be minus minus plus, that is your 1 by s plus a. So what we will get Laplace transform of this basic function if f of t is your e to the power minus at, and Laplace transform of this function is nothing but 1 by s plus a. So e to the power minus at, therefore e to the power minus at is your basic function. Laplace transform of this function is nothing but 1 by s plus a. So therefore Laplace transform of e to the power minus at is nothing but what, that is your 1 by s plus a. So this is your basic functions of Laplace transform of some exponential function e to the power minus at equal to 1 by s plus a. So next, that is your another function f of t is your, and second exponential function, that is your f of t equal to e to the power plus at. In previous derivation, that is your f of t equal to e to the power minus at exponential decaying, f of t equal to e to the power at. If f of t equal to e to the power at, now we are going to find the Laplace transform of f of t. So Laplace transform of f of t is your f of s, and the formula is your 0 to infinite, that is your f of t into e to the power minus st dt. So that is your what? So 0 to infinite, in place of f of t you will put e to the power at into e to the power minus st dt, and that will be your what? That is your 0 to infinite, that is your e to the power, if you taking minus common, that is your s minus a whole into t dt. So always if there is an exponential function, keep this power minus of something, because if we put infinite, e to the power minus infinite 0, that's why keep the term in terms of minus here, e to the power minus st at. So if you taking common minus, that is your what, minus st, and minus minus plus at here. So that's why you have rearranging this term and keep in this term e to the power minus of something, so that when you will put the upper limit, e to the power minus infinite will be 0. So keeping in mind and keep in this term e to the power, this term minus of something, so that if when you are going to putting the limit, that will be, you will get the value. So that's why, and how to integrate this value. So e to the power any function integration is nothing but e to the power that function, e to the power minus s minus a whole into t divided with respect to t, that is nothing but what, minus s minus a 0 to infinite, and the value is how much, that is your 1 by minus s minus a whole into what, if you put the upper limit in place of t, that is your infinite, e to the power minus infinite, that is your 0 minus e to the power 0, that is 1, and the value is how much, that is your 1 by s minus a minus minus plus, that is your 1 by s minus a. So therefore Laplace transform of f of t, which equal to Laplace transform of e to the power at equal to 1 by s minus a. It is very very important. So Laplace transform of e to the power plus at is nothing but 1 by s minus a. So this is your what, when application of Laplace transform, when we solve some numericals like your transients or any network functions. If there is a term containing e to the power plus at and first of all converted into Laplace transform, if there is a e to the power plus at, if it is plus, and this will be minus. And previous slide, if you will observe, e to the power minus at, if it is minus, and this becomes plus. E to the power minus at is nothing but s plus a. If it is minus, that's why it's plus a. If e to the power plus at, if it is plus, this will be minus. If it is minus, this will be plus. If it is plus, this will be minus. So that's why e to the power minus at Laplace transform is 1 by s minus a, 1 by s plus a. E to the power plus at Laplace transform is your 1 by s minus a. Then third functions. If I'll say that is your, already I told you Laplace transform of t, that is your 1 by s square. Laplace transform of constant function, that is your constant by s. Laplace transform of t is your 1 by s square. So Laplace transform of t to the power n, that is your factorial n by s to the power n plus 1. Then we have already derived Laplace transform of e to the power minus at, that is your 1 by s plus a, and Laplace transform of e to the power plus at, that is your 1 by s minus a. So if I will say Laplace transform of sin h omega t, sin h omega t. If I will say Laplace transform of sin h omega t, Laplace transform of sin h omega t. Here f of t is your sin h omega t, hyperbolic function. So already in hyperbolic function, sin h or cos h omega t, and as you know, sin h omega t is how much? Sin h omega t. In sin h omega t, that is your e to the power omega t minus e to the power minus omega t by 2. This is your sin function h omega t. If I will say cos omega t, and that is if it is your cos h omega t, that is your what? E to the power omega t plus e to the power minus omega t by 2. If it is minus, that is your sin, and plus, that is your cos. So therefore, now in this function Laplace transform of sin h omega t, and in place of sin h omega t, you can put e to the power omega t minus e to the power minus omega t by 2. So Laplace transform of e to the power, in place of sin omega t, you can put e to the power omega t minus e to the power minus omega t by 2. So as you know, that is your 1 by 2 Laplace transform of e to the power omega t minus Laplace transform of e to the power minus omega t. There is no need to derive. So already I told you e to the Laplace transform of e to the power plus a t in the previous slide, that is your 1 by s minus a. If it is plus, this will be minus. And Laplace transform of e to the power minus a t, that is your 1 by s plus a. So here in Laplace transform of e to the power omega t, here a is your omega. The value is how much? S minus omega. And Laplace transform of e to the power minus omega t, that is your 1 by s plus omega. So there is no need to again derivation of Laplace transform. This is nothing but e to the power omega t into e to the power minus st dt. Put the limit 0 to infinite, you will get 1 by s minus omega. So I can directly put, that is your 1 by 2, that is your what? Laplace transform of e to the power omega t, that is your 1 by, if it is a is your omega, that is 1 by s minus omega, that is your 1 by s minus omega, and minus Laplace transform e to the power minus omega t. If it is minus, this will be plus, minus 1 by s plus omega. And the value is how much here? That is your 1 by 2 whole into a minus b into a plus b, that is your a square plus b square. So that is your what? A square minus omega square. And this is your s plus omega minus s plus omega. Your LCM is nothing but s minus omega into s plus omega. And here minus s plus s, that will be cancel out. and that is your omega plus omega 2 omega, that is your what, 1 by 2 into 2 omega divided by a square minus omega square, and 2 will be cancel out, that is your omega divided by a square minus omega square. So therefore Laplace transform of sin h omega t is your what, that is your omega divided by a square minus omega square. So that's what the Laplace transform of sin h omega t, that is your omega divided by a square minus omega square. So what we have derived from this lecture 2 in the Laplace transform. So already I told you in your first lecture of Laplace transform. So Laplace transform of f of t, that is your f of s, and Laplace transform of t, Laplace transform of constant function, that is your 1 by, if any constant function, Laplace transform of constant function is your 1 by k, constant by s, and Laplace transform of t, that is your 1 by s square, and Laplace transform of t to the power n, that is your factorial n by s to the power n plus 1. Now today we have already derived the Laplace transform of some exponential function, that is your e to the power minus a t and e to the power plus a t. In Laplace transform of e to the power minus a t, that is your 1 by s plus a, if it is minus, and that will be plus s plus a, and then that is your Laplace transform of e to the power plus a t, if it is plus, and this will be minus, and then we have derived, that is your sin h omega t. In sin h omega t, you have to convert it sin h omega t, that is your e to the power omega t minus e to the power minus omega t by 2. That's why it is nothing but what, omega by a square minus omega square. So now today we will close this topic. Then next class we will discuss again more and more number of Laplace transform of any functions. Thank you.